because I have not recorded the audio. I forgot to click the audio option in the screen recording, so there will be some gap between the audio and my cursor. I will try my best to follow the video, but let us start with the introduction of today's task. This video is a bit advanced and a proper introduction of assembly language and assembly language relationship of this language with Proteus simulation needs a proper introduction, and we will do it in the coming video. So in this video we will perform some tasks in assembly language, and for our first example is we have wrote this copied this code from our book. Let us discuss what all these terminologies mean. LDI, we use LDI for giving a register some value. This is a function. Basically we can name our function with anything we like, obviously not any predefined term. Decrement, DEC, this register is basically used as a counter, okay, in the start. So this decrement is used as a counter, so the R16 will come from 10 to 0. BRNE basically calls the function back until the R16 basically doesn't become 0. Until then the function will run again and again. So that's about the function and BRNE. And after that the out port B, this will send this data in register 20 into port B. So this is basically the code, and let us go to the book and read the statement. Basically we should have read the statement in the start. Write a program to clear R20, means give R20 some value of 0. It must be empty. Add 3 to R20 10 times. Okay, we'll see that how we give R20 the value of 3 10 times. We'll give the register 21 value of 3, and then we'll add register 20 in the register 21 into register 20, and at the end it will, what will it do, that send the sum at the end to port B. Use BRNE. Basically I have told you that what BRNE does in action actually. So I think let us go to Proteus. Decrement is basically what will run the whole code, whole functionality of this task. We have forgot one thing, that we should add these both registers, the values of these both registers, and this is basically the pattern that R21 will be added into R20. This sequence is very important. Now let us come to Proteus, and in Proteus first of all we will give our file the name, and obviously later on we will select some location for our file to be saved. Let us give it as example 1 task 1, and then the location. One thing that is important here is that we will create firmware project, and in that we will select AVR. Okay, that's what we are using. And in the controller we will use ATmega328P, because we will be working with the Arduino UNO. So 328P, and that is almost finished. Here we have got this ATmega228P, and it's in source code. We will actually write our code, and let us a bit clean it so that we can see our code more clearly and understand it properly. We don't need this start function and start loop basically. Here, after very cleaning it, and we will see how we give R21 value 0, because we have to save values into this incremented by 3 by saving R3 value into R30, and then adding R30 into R20 basically. I have renamed this R21 into R30. That doesn't affect anything, and I've explained how it will add and then decrement, and then BRNE will start the loop again and again until the R16's value decrements to 0. So here the code is compiled successfully, and let's debug it, and let's see how the CPU registers show us it's working. 2-3 things that we will be focusing on: R16, R20 and R30. So basically the change will come into R20, and R30 will obviously be it will be the same. You will see it now. R30 is 3. So after this when we will reach to BRNE again into next step now. So R20 the value in R20 is saved as 6, now 3 and then 6, and then as we will and it's decrementing. R16 is will decrement. Now it's 7, and then 6, then 5, then 4, then 3, then 2, then 1, and at the end it will end up. But R20 will go into its maximum. It is basically 10 times 3 okay, in hexa. Obviously it will give us the value in hexa. Upon successful compilation we will debug it obviously, and we will see how the CPU registers show us the working. It's now a bit clean, and we will see what we will note. Actually, we will see that R16 will have 55 value whenever we will go to the command. Actually, it should be line 4 at which it will show 55, and basically after that in 21 register 21 the value should increase. We will see that. And the statement, obviously the statement was that to load port B register with the value 55, okay, and complement port B 700 times. So 55 should be there in the port 700 times is our target. Here I have given 71, but let us see, there is no harm in giving it in running the loop 710 times. There is no harm. We have just to see the working of this loop. There is outer loop, inner loop. So the outer loop will run 10 times. Every time it will enter to the inner loop, The inner loop will run 71 times. We have done a mistake here. It should be 70 and that should be 10, but the inner loop is basically 71 times here. So every time the outer loop will allow us to enter into inner loop, it will run 71 times. And so that when it ends 71 times for the first time, it will go back to outer loop, and the second time it will come in the third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So in the 10th time it will at the end it will become 710 times. The loop will it is basically a kind of nested loop. So this is how these inner and outer loops will work, and again and again it will end up giving us 710 times. Uh, let's come into now uh, R20 and R21. Look at them. It will basically R16 is given the value of 55, and now as we move on, we are seeing that the R21, the loop is basically the inner loop that is running. We will try to end it until it reaches 71 times, and so that we see, obviously we see that the inner loop is running, so that one time at least it go to the outer loop, so the code is justified and explained properly. This time the inner loop is running. Okay, remember that. Now we will try that this loop ends and we go into the outer loop. It is now 229 times, 28 times. You can see the register 21. So we are almost there to end the loop. It's now 10, 9, 8, 7, 6, 5, 4, 3, 2 and 1. Now it's only 2. Now one more time, and that is it. Now it will go out of the inner loop, and in BRNE loop out, it will go back to the outer loop. So now this is the second time it has come to the outer loop. Okay, and now again into inner loop, and again 71 times. So this is how this code works basically. Let's end this and move to the fourth and final code of our today's task. Let's copy this and paste it exactly into the Proteus source code, and I think we should remove this. We don't need that. And this is basically my location that is actually stored in R31, and we need 55 if it is 0 in the location 700, then it should be, let us see our statement. Location 200 is basically location 200. If this contains the value 0, so we have to put the location 55, whatever it is there is in location 55, we will put that into it. So this is the code, but we see that my location is not defined, and we will give it the address 0x200 with the dot eq my loc equals 0x200, and now the code is perfect, and we are almost ready. Let's compile it, and compilation is done successfully. Debugging is required. Okay, let us see the CPU registers. Now you have to focus on R30. There should come 55. So there it comes. Since there is nothing in next, obviously, so it is 0, obviously. Okay, so the value 55 is put into it. That was it for today. Today we have just covered some tasks without going into the details of assembly language, and in the next video we will inshallah go into details. Thank you.